Hi there and welcome to SYS Systems. I'm Rob Thompson and this is Matt Jones, Senior Application Engineer from Stratasys. And today we're going to give you a quick overview of the H350, which is the SAF technology. So Matt, over to you. Bit of a walk around the SAF machine if you do, please.
So our first sort of foray into the powder world, the H350, so SAF, Selection Absorption Fusion, powder-based system, currently running PA11. Obviously on the roadmap there are newer materials like PA12 and PP that will eventually come. But if you could just lift the lid for me. Sure. So in the inside we have two sleds. We have our build chamber on the inside, and we have the powder wave or the big wave management system where we are recycling over 70% or 70% of the actual powder. Temperature control at the top, the IR lamps and what have you. Front left hand corner is basically where we put the powder inside the machine, and funnily enough the cap is actually is a printed component of it as well. So it's where you put your dosages in on the inside. And on the right hand side over here is where we put our absorption fluid on the inside. So SAF system, it's powder based, PA11, really good for different applications, but it's more of mass manufacturing, so thousands upon thousands of parts per year that you can produce on the machine.
So that's it. So really you wouldn't be talking about this type of technology for a prototyping application?
Not really, no, unless you want to, obviously you can prototype your parts first before you go into the manufacturing. So the idea of going from the initial design phase, validating the design, and then going into production, sure, you could do that, yeah.
Yeah, so we're seeing these going really into original equipment manufacturers, yep. People who are producing their own systems, trying to reduce down their tooling costs, and also sort of service providers as well, I suppose.
Yep, so service providers is a big part of it, but as you just mentioned, if you've got antiquated equipment where you can no longer get the spare parts for it, it makes perfect sense to design or redesign a part and then print 500, 5,000 of, or whatever it may be, on the machine for each type of vehicle or whatever it is.
Makes a huge amount of sense, yeah. And I'm guessing a lot of times tooling cost is a real prohibitive factor when people try to make mass customised parts or complex parts. The thought of going into those tooling costs is really stopping people being more creative, I suppose.
It's the tooling cost is prohibitive as well, because there's the design cost of it, there's the tweaking of the tools, so you're not maybe getting it right first time. So all of that cost, plus it's machined out of metal or Delrin or whatever the polymer may be, it's very expensive, and it's not very sustainable as well. I know we're printing with a plastic powder, but this is far more sustainable really than going down the traditional route of making tools.
That's it, you're only using the actual amount of material that you want for
just
the
what you want,
part.
where you want it. Yeah.
That's it. And I suppose one thing we're sort of overlooking there is the lead time for tools. So if you're having a machined mold tool, that might take weeks, if not months, if you're going abroad.
Yep.
And whereas here you can design the part, maybe prototype the part using this process or another, and then once you've locked that down, you can repeat that job as the demand comes in for that particular part.
Yep. Lock it off and pick it up as and when the business comes back in, or increased demand as well. Sort of roughly about 18 hours for a full build, let it cool down overnight. Obviously the machine can be continued to print over that time, so you can put more and more on. But yeah, it makes perfect sense.
So people really creating a digital inventory of components. So with the actual process itself, there's other powder-based systems out there on the market like SLS and other different processes. What really stands out with this machine, in terms of its high-level sort of benefits?
Yeah, so it's a very quick system, much tighter temperature controls than our closest competitors as well. The sleds that move in one direction as opposed to different directions, so you get much more uniform control of the temperature over the build chamber. You don't get as many cold spots or hot spots. So much more uniformity gives you the ability to get accurate parts all over the build tray, all the way through the nesting, and much denser nesting as well. So you can fit many more parts in. Although the chamber might be slightly smaller than our competitors, you're actually getting more volume of production from it just because of how close we can nest those parts together. So other competitors may get orange peel effect or poor surfaces or warping and distortion. You don't get that with this because of the way we do the big wave powder management and the temperature controls on the inside and the single absorption fluid. So instead of having two fluids to irradiate with the IR, the heat, it's only one.
Right, so it's all about the throughput, the cost per part, and then the material properties with this technology.
Yep, which gives you the cost per part much cheaper than our competitors as well. Yeah.
Fantastic. So if you're interested in how powder-based technology like the H350 could be utilised within your manufacturing process for production components, or even offering a service out to your customers, then please do get in touch with us. We can have a chat in depth about your applications. We can bring Matt on site as well, and we can come and have a chat about how this technology can transform your business.